Let's um, do this next question about groups of polynomials. This is kind of a different question, but it's kind of interesting as well. It's 8 marks. So the solution is kind of long, but it will be fun to do. So by finding the cubic equations whose roots are alpha, beta, and gamma, solve the set of simultaneous equations. Okay, so this is kind of easy because you can manipulate these uh, any way you like. So the first one, alpha, beta, and gamma, that is the first thing you always look for. Alpha plus beta plus gamma is equal to -1. That means that let me write the general equation first so it's easier to understand. I'll write it on the left side. Um, x cube, let's write it ax cube plus bx squared plus cx, and let me just get rid of this one so it is easier for us to understand the question. Plus d equals to 0. This is the general form of the cubic equation. So first off, we can figure out something relatively easily. So they say alpha plus beta plus gamma equals to -1. All right. So we could say that this b equals to 1 because minus b over a equals to -1. So b would be equals to uh, 1. Yes. So we could say this and like we could consider a as one as well, but we aren't sure about it. So let's just assume that this is true. Let's assume this is true. Let's take b as 1. So we can write this and a as 1 as well. So we can write this as, writing. All right. So we can write this as x cube plus x squared plus cx plus d. Okay, so the next thing we're going to find is C. The next equation in the simultaneous equations that they have given is alpha squared plus beta squared plus gamma squared. You might remember, you should remember the identity I taught you. That was not this. Let me just write this completely first. 29. The identity was alpha plus beta plus gamma whole squared equals to alpha squared plus beta squared plus gamma squared plus 2, and then the sum of pairs of roots. Okay, the sum of pair of roots. So we can just rewrite this as this is alpha plus beta plus gamma. We have been given this in the question, that is just -1. So this would just be -1 squared and then equals to the next part is alpha, beta squared, and gamma squared. The addition of those we have been given those as well, which is 29, and then plus 2. And I'm going to do something different just so you know what I'm trying to do. The sum of the pair of roots is, as you remember, C over A. So I can just write that as C over A. Let's continue with the next. So this is just going to be 1 and then equals to 29 plus 2c. 2c because a was 1, so c over 1 would just be c. So this would be minus 28 over 2, which would be C. C would be minus 14. We got the C value as well. Now for the last value, D. D is the product of the roots of the cubic equation. D would be, let me just write it down, D over A minus D over A, my bad. Minus D over A would be alpha, beta, and gamma. So let's try to find this with the last equation. We can take the common denominator alpha, beta, and gamma. As you may notice, we already got the value we need. We just have to solve to figure it out what we'll get. So this would be beta gamma plus alpha gamma. Let me extend that. And then alpha gamma and then alpha beta, which would become minus 1 as well. So with this logic, the top part of this, the top numerator, is the sum of the pair of roots. As you can see, beta gamma, alpha gamma, and alpha beta. This is the sum of roots, the sum of pair of roots. So we can just write that as C over A, which would be minus 14. Minus 14 over alpha beta gamma. Let me just scroll down a bit so you can see. Yeah, here it is equal to minus 1. So this can just be 14 equals to alpha, beta, and gamma, which would just mean d over minus d over a equals to not minus 14, it would be 14. So a is just 1, so this would be d is also equal to minus 14. Write that down, minus 14. So the final equation that we get for this question is x cubed plus x squared minus 14x minus 14. We can also check our answer by comparing the values we get from this question and comparing them to the ones we already had. For example, the sum of roots is minus 1. Let's compare it from here. The formula for the sum of roots is minus b over a. So this would become minus 1 over 1. So this just becomes minus 1. That checks out. And then the rest can also be checked. But I think the first one is enough to solve. You should be confident in your working, so you know what the answer is confirmed. And because you need to save time in the exam, you don't have much time. The time may seem a lot, but it's genuinely not enough. So you have to be quick while doing the question. So this is our final equation. I hope you understood the question and see you all in the next video with one last question for this chapter or maybe another one if I find a good one. And then I'll start a chapter for statistics, paper 4 for the mathematics. And then I'll go back to paper 1. I'll keep switching between statistics and for the mathematics paper 1. Okay, so as I was reviewing the question, I figured out that they asked as well to solve the set of simultaneous equations. That just means we have to find the solution to alpha, beta, and gamma, what these could be. So with this equation, there are two methods we can use for this. Let me just do them here. The first one is kind of a method that only works on a few cubic equations. The second method would work on all of them. So like let's do the first method. That would be take the common x squared, then x plus 1, and then minus 14 x plus 1. Then we can just take x plus 1 common, x plus 1 common from both, and then x squared minus 14 These both are equal to 0, by the way. And then the answer just becomes x equals to minus 1, x is equal to square root of 14, and then x is equal to minus square root of 14. These are the three answers we get. Okay, that is not, that is 1. So these are the three answers we get: negative 1, square root of 14, both positive and negative. This is the first method. The second method is, let me just scroll a bit towards this side. The second method for this would be to, okay, that's perfect. So the second method to solve this would be to first give it the value as, let me move a bit to the left. Okay, f x equals to x cube plus x square um minus 14 x minus 14. Okay, so there is a rule in polynomials that you, if a number, for example, this is just an example, I'm not like saying that this would be the answer, this is just an example. For example, if f1 equals to 0, then x is equal to 1, x minus 1, this thing would be a factor of this equation. A factor means that this can be factored out of the equation to make it into a quadratic equation and a linear equation. Linear equation are the equation with 1 degree only, and quadratics are with 2 degrees. So it can be divided into two. So we can figure this out by trial and error, and this doesn't take long because the factor is close to like it is between minus 3 and 3, so we can just like trial and error. Let's test out f1 first. So f1 on calculator, it would be 1 plus 1 minus 14 minus 14. So that gives us minus 26. So that is not possible. That is not a factor. So let's try f2. That would be 8 plus 4 minus 28 minus 14. That gives us minus 30. So that is not a factor as well. Let me just write that down. You have to show this working a bit in the exam as well if like you want the full marks in the question, because you have to show the trials you did. So let's try f minus 1 on this. Let's try f minus 1. So this would be minus 1 plus 1 plus 14 minus 14, and that gives us a 0. And we knew this would be the factor because of the previous method, but I just want to show you the trials which I do to find this. So this would just become, let me fix that 1 second. Uh, x equals to minus 1. So this would just be x plus 1 equals 0. Right? So this thing, x plus 1, that is our factor. So we can just write it as, we have to do the long division now to find the quadratic equation with our original equation, which is going to be x cubed plus x squared minus 14. I should move it towards the left a bit because that we need a bit of space. That is not left at all. So let's move a bit towards the left. All right. Perfect. So this is going to be your long division x cube. Let's just go quickly through it. I hope you know this from maths paper 3, the 9709 board. But if you don't, just like follow what I'm doing, and I hope you understand. I will be making a separate video on these small concepts later on. But for now, just follow along or like watch another video of channels like Math by Saad or Zenomatics. So this is going to be X plus. This is why this question had 8 marks. The working is pretty lengthy, and this can be solved pretty quickly in like 8 minutes or 7 minutes. I'm just doing it slowly, so you follow along with me. This would be x squared, and then minus x cubed, then minus x squared as well. So we'll just get minus 14x and then minus 13 as well. And then we can do minus 14, and this would just become 14x plus 14, and there is no remainder, of course. So this is the quadratic we get. We'll scroll down right there. So the final equation we get by factoring out x plus 1 is x squared minus 14 equals to 0. This method works on every cubic equation, by the way. So this is going to be not that. This is going to become x plus 1 equals to 0, or x square minus 14 equals to 0. This is going to be x is equal to minus 1, and x is equal to plus minus square root of 14. Let me just fix some minus 1 so it looks a lot better. That is the same solutions that you got right here, and also now again with this one right here. So I hope you got that, and I'll see you all in the next video.